This video has over 9 hours of content and contains 21 unique Python projects. These projects go in ascending order of difficulty, so the very first project in the video is pretty simple. It's just teaching you Python, completely designed for beginners, and as you go through the projects, they get harder and harder and harder and harder until you get into some pretty advanced stuff. We have games, we have using APIs, we have scripting, we have automation, we have fun tools, we have alarm clocks. Anything you can imagine is probably in this video, and there is definitely a project that you will enjoy and you can learn from. In terms of navigating here, all of the projects will be timestamped in the description. I've made this so it's really easy to find the projects, and all of the links in terms of code resources, assets, sound effects, whatever you might need for the project will be linked directly below the timestamp. So let's say you're at project number 4. Well, what you can do is go down to the description, find project number 4, find the timestamp for it, and you'll see beneath there'll be a link that contains all of the code for that individual project. Now, just for your information, this is simply a combination of a ton of other Python videos that I've done in the past. I had so many on my channel, many of which you guys didn't even know exist or new subscribers haven't seen. So I wanted to make one massive resource that just had so much practice that you can save this video and come back to it for days, weeks, or even months and constantly have a new project to work on. I hope you guys are going to enjoy this. It's taken me a fair amount of time to edit it, and I've chopped out all of the intros and the outro so you just get right into the content, no fluff, straight to the point, and right into practicing your Python skills. If you guys enjoy this type of content and you like my teaching style, I do have a software development course. I'll leave a link to it in the description. Check it out, and I hope you enjoy this video. So this quiz game, the idea behind it is we want to ask the users a bunch of questions, and then if they give us the right answer to these questions, we'll kind of add 1 to their score. Then at the end of the program, we'll print out what they got out of the number of questions. So if there was 10 questions, we would say, hey, you got, 3 out of 10 or 7 out of 10 or whatever, and maybe we'll even give them a percentage or something like that. So let's get started. The first thing I'm going to do here is use the print command or the print function. I'm going to assume you guys are familiar with this, but when you want to print something to the screen, output something to the console, you say print, you put some value in here. The value you typically put is a string. A string is anything encapsulated in double quotation marks or single quotation marks, and then this will be what is outputted. So the first thing I'm going to do is just kind of welcome my users to the game. I'm going to say, welcome to my, and then computer quiz. So the specific quiz I'll go with is a computer quiz. Please feel free to go with whatever type of quiz that you want. All right, now we've welcomed the user to our game. Let's just quickly test this out. In VS Code, to run your code, you press this little kind of run button right here. You're going to see it should open up a terminal down here. And then notice it says, welcome to my computer quiz, because the program just ran. Awesome. So now what I want to do is ask the user if they want to play my game. If they say, no, I don't want to play, then we'll just immediately quit the game. So to do that, I'm going to create a variable. I'm going to say playing is equal to, and then I'm going to use this function called input. Now what input allows you to do is ask the user to start typing something in the console. So inside of input in here, you put what's known as the prompt. Now the prompt is kind of what appears before the user can start typing. So for example, if you're asking the user for their name, you may have the prompt be name and then colon and then maybe a space. And then right here after this space, the user could start typing whatever their name was. So in my case, I would put Tim. And then whatever they type after the prompt, and then when they press enter, that will be stored in playing. So if I type Tim and then I press enter, now playing will be equal to Tim because after the prompt, that's what the user typed before they hit enter, right? Hopefully that kind of makes sense. And even if the user has a space, they say like Tim and then R, all of this Tim space R will be included in playing because this is all the stuff they typed after the prompt before they pressed enter. So I'm going to ask them here, do you want to play? Question mark. And then I'm going to add a space here. The reason I'm adding a space is because if I don't add a space, then the user is going to start typing right on the question mark, and that's going to be kind of all smushed together and it doesn't look nice. And so we're going to add a space to make sure the user starts typing 1 space after the question mark. All right, so now if I run my program, so I press the run button, it says, welcome to my computer quiz. Do you want to play? Notice the cursor is here, and now I can start typing whatever I want. When I press enter, nothing's happening because we haven't done that yet. We haven't configured that, but that's kind of the basics. That's how you get user input. And just to show you here, if I print out playing, what this will do is give me whatever the value of this variable is. So if I run this here, it says, welcome to my computer quiz. Do you want to play? Say yes. And then it prints out yes, right? So pretty straightforward. Okay, so now that we know if the user wants to play or not, right? Because after this line is done, we'll have something stored in playing. We want to check if the user typed yes, right? And specifically, if they didn't type yes, we want to end the program. So what I'm going to do is use something known as an if statement. Now, an if statement allows us to conditionally check or compare values together and see if something is true or false. And so I'm just going to write out the kind of entire if statement, and then I'll run through it step by step. I'm going to say if playing does not equal to, so an exclamation point and then the equal sign, and then I'm going to say yes, then what I want to do is I want to quit the program. And there's this function in Python that you can use called quit, and this will just immediately terminate the program. So what I'm doing is using if. I'm writing what's known as my condition. This is the thing that I want to check. So I want to check if the variable playing, which is what the user typed in, is not equal to yes. The reason I'm checking if it's not equal to yes is because if they typed anything other than the word yes, I want to quit the program. Whereas if they typed yes, I don't want to quit. And so what happens here is we're going to compare whatever the user typed in with yes. And since we're using not equal to, if what the user typed in is not equal to yes, this condition evaluates to a Boolean, which is known as true. And then if this is true, right? So if whatever the condition is true, then whatever is indented after this colon here is going to be run. So hopefully that makes sense. I won't go too much more into the syntax. I assume you guys can probably figure it out yourself. But the idea is you put a colon, and then all the stuff you want to happen when this condition is true, you indent here. And an indent is kind of 4 spaces. I would recommend you use tabs rather than kind of going 1, 2, 3, 4. You'll get some issues with your indentation if you try to do spaces and tabs together. So anyways, let's just see this now. Let's run this program. Okay. I'm going to say, welcome to my computer quiz. Do you want to play? I'm going to type yes. And well, the program's going to end regardless because we're not doing anything after this if statement. But if I go here and I print, okay, exclamation point, and then let's play, smiley face. Oops. Okay. I need to fix my quotations here. Yeah. Okay. That's all good. Let's run this now. It says, welcome to my computer quiz. Do you want to play? I'll type yes, and it says, okay, let's play, right? And then it gives a really bad smiley face that I need to fix. And if we run this one more time, and then this time we type no, notice that it doesn't say, okay, let's play, because this condition was true, and so the program quit. All right, so that's about if statements. Hopefully that all makes sense. We're going to be using a lot of if statements in this video. So now that we say, okay, let's play, what we want to do is ask the user their first question. And so what we're going to do is the exact same thing we did when we were asking the user if we want to play. We're going to say some variable. I'm just going to call it answer because that seems to make sense, is equal to, and then input. And then I'm going to put whatever the question is. I'm going to say, ask something about a computer. I'll say, what does CPU stand for? Question mark. And then what I'm expecting is that the user is going to type in the answer, right? And so what I'm going to do is just add a space here to make sure that, again, the user's not typing right beside the question mark. They have a little bit of space. And now what I want to do is check if the user's answer is equal to the correct answer. So I'm going to say if answer is equal to, and then I need to type out what the actual answer is. Now, in this case, this is central processing unit. And I think I spelled processing correct. Obviously, you're going to want to make sure your answers are actually spelled correctly, because even if the user types in central processing unit, but they forgot the G, or they spell something wrong, or they have a capital P, they're going to have the question marked as incorrect because the answer has to match exactly with what the user typed in. Okay, so now we have a colon, and now we're saying, okay, well, if the answer was equal to central processing unit, what do we want to do? I'm going to print that they got it correct. So I'll say correct like that. And notice I'm using single quotes and double quotes kind of interchangeably. It doesn't matter which one you use, so long as you're consistent with the starting and ending quote. Awesome. So let's just run this now and see if this works. So I'm going to press run. It says, welcome to my computer game. Do you want to play? Yes. Okay, let's play. What does CPU stand for? Central processing unit. And then it gives me the output saying correct. Now, if I run this again, do you want to play? Yes. Okay, let's play. What does CPU stand for? I type in just CPU. It doesn't give me anything because, well, this was not true. Sweet. Okay, so now the thing is, though, if the user gets this wrong, I want to tell them that they got it incorrect, right? We need some output saying, hey, no, that was not correct. And so what we're going to use now is what's known as the else statement. So whenever you have an if statement like this, and you are checking if something is equal to something else. And that's what the to equal sign is doing, or you have some condition here. If this condition here does not evaluate to true, you can put this else statement here, which means if this is not true, whatever's in the else statement will run. So if I go here and I say print incorrect exclamation point, now if this is false, so if the answer does not equal central processing unit, then we will print out incorrect. If we type anything, doesn't matter, just so long as this right here that we typed out is equal to false, whatever's in the else here will end up run. So let me just show you what I mean, and then we can talk about this a bit more. So let's run. Do you want to play? Yes. Okay, let's play. What does CPU stand for? Central processing unit. And then it says correct. And oops, I should have typed in the incorrect one, but that's fine. Let's just type in no. And then notice it gives me incorrect. And if I ran this one more time, type yes, and I type some other random thing, it still gives me incorrect. So if I type anything other than central processing unit, the else statement runs. And again, the syntax for the else statement is you write else, you do a colon, and then any stuff you want to run, you do indented after the else. And you could do multiple things as well. I could do another print statement, and then both of these print statements would run if we got this question incorrect. Sweet. Okay, so now we have our first question. And now what we can do is kind of just copy this to do the rest of our questions, right? So I'll copy this one more time. I'll do 4 questions for my quiz. Please feel free to do more. And it's totally fine if we want to leave this answer variable the same. I don't need to change this to be something else. We could if we want to, but since we are done using the answer for this question after this if statement, it's fine if we use the same variable to store the answer for our next question. So now what we're going to do is we're going to kind of remove all of our answers and questions. And we're going to type in, well, new answers and new questions. And I'll show you some more things that we can do here and kind of some fixes and all that as we go through, but let's just get our questions done first. All right, so now my next question, I'll say, what does GPU stand for? Question mark, and then this will be, and I'll copy this, graphics processing unit. Okay, so let's go. Graphics processing unit like that. I hope that's correct. And then the next question we can ask, I'll just do a bunch of acronyms. What does RAM stand for? Question mark. This will be random access memory like that. Okay. And then lastly, we can say, what does PSU stand for? Question mark. And we'll just say power supply like that. Sweet. So now we've got all of our different questions here, and we're kind of printing out whether we got them correct or incorrect. So let's just quickly test this out. Let's make sure this is all working. So do you want to play? Yes. What does CPU stand for? Central processing unit. What does GPU stand for? Notice I didn't add the space here, and since I didn't add the space, you're going to see when I start typing here that's kind of smushed with the question mark. So I'll say graphics processing unit. What does RAM stand for? Random access memory. Okay, and what does PSU stand for? Let's just type PSU, and then notice it tells me incorrect. So I'm going to start by fixing these spaces here. You guys saw what happened when I didn't add the space for the input. So now it should be all spaced out properly. Sweet. So now we've got this all working. Hopefully you guys are all familiar with this if and kind of else syntax now. It just needs to be in this structure. Whenever you have a colon, typically in Python, the next line after that does need to be indented. If I did this, and like I didn't indent this line here, you can see we're getting this red highlight. And it's the reason we're getting that is because the indentation's all messed up. This is supposed to be indented after we have the else statement. And a small note, you can only have the else statement after an if statement, right? So I can't just randomly come down here and put an else statement. It needs to come after an if statement appears, right? So hopefully that's clear. Okay, so now the one thing that I want to show you, though, is that we might be getting some kind of weird results from our program that we don't expect. So I'm going to run my program, and I'm going to say, do you want to play? And I'm just going to type yes with a capital Y. And notice when I do that, it doesn't actually start my program, right? It immediately quits. And the reason for that is whenever you have a capital, that is different than lowercase, right? So if you have yes, that is not equal to yes. These are different strings. And so if we want to check if the person's answer, regardless of the case, right? If they have a capital Y or a capital E or a capital S or something, or, you know, multiple capitals, if we want capital Y, capital E, lowercase s to be valid and to allow the user to play, we need to do something. Now, there is this method in Python called .lower. And what .lower does is it takes whatever text we type in and it just makes it completely lowercase. So if I go here and I print, Tim is great like that. And then I say dot lower. And actually, let me do this in another way that's not as confusing. Let me say text is equal to this. And then I say text dot lower. What this will do, and make sure you have the parentheses, by the way, is it will convert all of this text to lowercase. So if I just run my program here and we have a look at our terminal, notice that, I have to type something. Let's just type that. It says Tim is great, all in lower cases. And so we can use this here to convert all of the answers that our user types in to lower cases. So I can say playing.lower, and then if the user typed in something with capitals, it will just all be lowercase. And that way, if they type yes with any different casing, it will still evaluate to true because we're converting it to lower. Now, in the same fashion, there is something called upper. If you say .upper, it will convert everything into upper cases. And so then what you would do if you're using .upper is you would make your answer in complete upper cases because you're always going to be converting anything lowercase to uppercase. So hopefully that's clear, but we're going to just throw .lower on here to all of our answers. So I'm going to say .lower, I'm going to say .lower, I'm going to say .lower, going to say .lower. And alternatively, if you didn't want to do it this way, you could actually just do it at the end of this input here. You could say input .lower, and then you could just remove this because now your answer is already converted to .lower. So you don't need to convert it kind of in this condition right here. Okay, hopefully that's all clear, but yeah, that's just taking your answer, converting it into lowercase, and then you're checking if the lowercase answer is equal to, well, the lowercase answer you actually have. All right, so let's rerun this. I'm going to open up my terminal. I'm going to run. Do you want to play? I'm going to type yes with a capital Y. Notice this works now. And now I'm going to do some capitals. So central processing unit. That works, right? GPU, graphics, processing unit. And then you get the idea. I won't do the rest of them. Okay, so the last thing I want to do here is implement some notion of score, right? We want to be able to tell how many questions our users got correct. So what I'm going to do is make a variable here at the top of my program. I'm going to say score is equal to 0. This is going to allow us to keep track of how many correct answers they have. Now, all we have to do here, since we define score equal to 0, is every time the user gets a question correct, we just need to increment score, so add 1 to score. So inside of this if statement here, because this is if the user got it correct, right? I'm going to say score plus equals 1. What that says is, okay, take the value of score and add 1 to it. That's equivalent to saying score is equal to score plus 1. So hopefully that's clear, but that's a way that you can just add 1 to the variable. And so if we add 1 to score every time we get something correct, that means that at the end of our program, we'll have some number, right? We'll have 2, 3, 0, whatever, however many questions we got right. And we can then use that to display how well the user did. So I'm going to say score plus equals 1. I'm going to do this inside of all of these if statements here. Okay. And now we've added 1 to score. So now what I can do at the very end of my program, once we're done with all our questions, is I can say you got, and then I need to use a plus sign. This is a concatenation operator. I'll discuss this in a second. Score plus, and then questions correct exclamation point. But I need to convert this to a string. So let me go through what I just did here. Okay, so I said you got, I did a space. Notice I manually added the space here. I then had a plus sign, and then I said string, score, and then plus questions correct. So the reason I'm doing this string here is because score is a number, right? Score is an integer. It's not a string. And so if I tried to do something like, Tim plus 1, well, this doesn't really make much sense, right? Because I'm trying to add a number to a string, and how do you add 1 to text? That's just an undefined operation. That doesn't exist. So what I need to do instead is convert this 1 to a string. Because now that I have 2 strings, when I add them together, what I get in Python is Tim1, right? They kind of get combined. And so that's what I can do. I'm going to convert this score here into a string. So then when I add it to the other strings that I have here, it's valid. This operation works, and I'm not getting some issue popping up. Okay, and then I'm adding the questions correct. So I'm kind of putting this string score in the middle of the string, right? You got whatever the number is, questions correct. Okay, so let's run this. And you want to play? Yes. I'm going to say, let's CPU stand for central processing unit. Okay. Graphics processing unit. Okay. PSU. RAM. And it says incorrect. You got 2 questions correct. Right now it's giving me how many questions I got correct. And so the very last thing we can do here is we can copy this line and we can give them kind of a percentage, right? Like you got 50% or you got whatever percent. And the way we do that is now we're just going to take our score, we're going to divide it by the number of questions that we have is 4, and then we're going to multiply all of this by 100, right? And if we want to be extra clear here, what we can do is put parentheses around this score over 4 to make sure this operation happens first before we multiply by 100. But you'll see if we did it the other way around, we didn't add the parentheses, it would still work fine because we would do the division before we did the multiplication. But anyways, we're going to say now, instead of you got questions correct, we're going to say you got, and then we're just going to add a percent on here. Now notice I'm not doing a space, and since I'm not doing a space, it's going to be whatever this number is, and then plus, and then the percent sign. So it'll come right after, and then we can do a period. So now we've calculated the percent. Again, just taking the score, dividing it by our number of questions, which is 4, and then multiplying it by 100. Now note here, if you change the number of questions, you got to change this number, right? So let's go here and let's run this. And let's go to our terminal. Yes, we'll play. I'll just type something random. Okay, random access memory, correct. And then power supply. And then it says you got 50%. You got 2 questions correct. And with that, that is going to wrap up our first Python mini project. So I know I went really slowly through this and really explained everything in depth. That's because this is the very first project. I'm trying to make sure this video works for everyone, regardless of your skill level. And now I will go a little bit faster. I won't re-explain a lot of the syntax that I've already explained now as we move into the new projects. Just anything new that I kind of come across or that we use, I will explain, but this is our first project. This is the quiz game. There will be some code that has, or there will be a link, sorry, that has this code in the description if you want to download this yourself. But I would highly recommend you modify this, change it around, maybe add like more than 1 point for questions that are worth, more than 1 point that are more difficult or something like that, right? And you guys can do this as you please. Regardless, that is the quiz game. Now we're going to move on to do a number guesser. I think this is the one I was saying I was going to do second. So this one is pretty straightforward, but what we're going to do is generate a random number, and we're going to track how many times it takes the user to guess this number. And so what I'm going to do is zoom in a bit here so that we can see our code. The first thing I'm going to do is import this module in Python called random. All right, so first thing to mention here is that this right here is what's known as a module. So when you import random, you're importing the random module. Now this just lets you use all of the functionality that's kind of in here. This is default. This is installed with Python by default. You don't need to install it or anything like that. And quick note, there is modules that are built by, people like me or other developers out there, and you can import them, but you have to install them first. This one is just built into Python by default, and so no installation is required. Anyways, let me show you how to make a random number. So there's a few different ways to do this, but the 2 simplest ways are to do random dot and then rand range. And then you're going to do an open and closing parenthesis. And let me get rid of the print statement so we can see this better for right now. And here you're going to put the start and then the stop of the range for your random number. So you would do something like -1 if you wanted to start the range at -1 and stop at 10. Excuse me. And then what this would do is generate a random number that goes from -1 to 10, but does not include 10. So that's very important. The number you put here is the absolute upper bound. You cannot have the number 10 be generated if 10 is here. If you wanted the range to generate a number between -1 and 10, you would have to put 11. Again, I don't know why they do that. There's just some things in Python that aren't necessarily intuitive for beginners, but with this is 11, it's not going to generate 11. It will generate up to 10. So make sure that's clear. Now, there's another thing you can do here. If you want the range to just start at 0, you can say random.randRange and just put the stop. If you just put one thing here, what this will do is generate a random number between 0 and this number -1, so up to 10. And yeah, there you go. That's how that works. Okay, so let's do something from -5 to 11. And let's say r is equal to random.randRange. And let's just print r. Okay, so let me run this. And we'll look at our thing here. Okay, run. And notice we get a 5. Now, if I run this again, we're getting a -3. I run a bunch of times, we get a bunch of random numbers. You see, this is random. And there you go. That's working. We got a 9. We can just run a bunch of times. We got a 10. Notice we won't get 11 if we do this. Sweet. So we're getting a random number. So that's one way. Another way to do this is with a function called randint. Now, randint works the exact same way as randRange, except now it will include 11. So the upper bound range now includes the number that you typed, doesn't go up to, but not included. So now if I do -5 to 11, 11 will possibly be generated. So if I run this now, we get 6, right? And if we keep running it, we might see that we get 11. Okay, I'm not, this could take a while. Yeah, there you go. So we do get 11, so that works. Okay, sweet. And same thing here. If you decide to not include the start, it will just generate up to and including this end number that you put right here. So that's how you make a random number. So what we want to do is generate a random number. So actually, let's leave this here. Let's say random underscore number. And then we want to ask the user to guess this number. And every single time they guess it, we're going to tell them if they were above or below the number so that they can do it in like a reasonable number of guesses, especially if we make this number like really large, right? So the first thing I'm going to actually ask the user is how large of a number they want to generate. So we'll assume it starts at 0, and then we'll ask them to type in a number, and we'll generate up to that number. So I'm going to say, let's say top of range is equal to, and then input, and we'll say type a number. We won't even tell them what it's for. We'll just say type a number. Okay, so now they're going to type a number. So what we actually need to do here is we need to make sure that this thing they typed in here is a number. Because if the user types in like hello or Tim or some random string, something that's not a number, then we can't use that, right? And we also need to make sure the number they type in is greater than 0. So I'll show you how we do that. I'm going to say if the top of range dot is digit, okay? And then I'm going to do an if statement inside of this if statement. I'm going to say if the int, and actually we're going to do this. We're going to say top of range is equal to int top of range. And let me pause here and explain what I'm doing. So first of all, you can make a variable using underscores. When you want to have multiple words, it makes a lot of sense to make the name with underscores. So like top underscore of underscore range. You can't have a variable that's like top range. That won't work. You need to have it connected. You can't have like 2 separate words like that. Anyways, this is equal to input. The user is going to type something in. Now, by default, when the user types something in, it's going to return it to us with double quotation marks. So it's going to be a string. So even if the user types in like 25, it's going to be returned to us like this. And this here for Python is not considered a number. It's not considered an integer. It's considered a string. And so we need to convert this 25 so that it looks like this, so that it's actually a number. And the way you do that is you use this function called int. So you surround the string with int, and then it will convert this string into its numeric representation, so it will give us 25. However, if you try to convert something that's not an actual integer into an int, it's going to fail. You're going to get an error. And so we need to make sure that what the user typed in is a digit before we try to convert it into an int. And the way you check that is with this isDigit method. So I say if top of range dot is digit, what isDigit will do is return to us true if this is a number, otherwise it will return false. And so if this right here is true, we will convert top of range into an integer. So top of range is equal to int top of range. Then we will check if top of range is greater than 0. So we'll say if top of range is, actually we're going to say less than 0, less than or equal to 0 specifically. Then what we will do is we'll print out, please type a number larger than 0 next time, and then we'll just quit. So we'll tell them what they did wrong, and then we're just going to quit the program right there. Otherwise, if we make it through all of this, we're good. But one thing we need to do here is we need to put an else, and we need to put quit, and we need to put a print statement that says, please type a number next time. So let me run through this. What we're doing is checking if it is a digit. If it's not a digit, so in the else statement, we need to tell them, hey, you got to type in a digit. This doesn't work if you don't type in a number, right? And then we quit. Now, if that works, if it is a digit, we convert it into an int. We make sure it's greater than 0. If it isn't, then we tell them, hey, you got to type in a number, and then we quit. But if we make it through all of this and we don't quit, so we've now converted the number to an int, we can now use that number to generate our random number. So we can say random number, random.randint, and then we can put top of range as our variable for generating that random number, and we'll now generate up to whatever number they typed in. Sweet. So now that we have that, let's just print out the random number, and let's just test this and make sure it's all working. So I'm going to run this, type a number, let's type 5, and we got one issue, randint missing one potential argument b. Okay, so this is my fault. I was saying when we used randint, we could just include the top of the range, That's false. We need to include the bottom of the range as well. So I'm going to put 0 there, and now this should work. So let's run this, and let's type a number. Let's type 5, and there you go. We generated a random number, which was 4. If we run this again, type 5, we get 3. You can see this is indeed working. Sweet. So now that we have our random number, we want to keep asking the user to type in a guess for the number until they get it correct. And so I'm going to use a while loop here, and I'll explain how this works in a second. I'm just going to say while true. Now, what this means is, okay, we're going to do whatever is indented after this while loop here, after the colon, while this condition, whatever's at the top of here, is true. So right now, if we just decided to like print Tim, this would happen infinitely. This loop would never stop unless we actually like manually close the program. The reason is because there's no way for this to end, right? I say while true, well, true is always true, and so we're just always going to print 10. However, there is this keyword, it's called break, and what break will do is immediately stop the loop as soon as this line of code is executed. So what we can do is use this break keyword to break out of the loop, stop running the loop as soon as the user types in the correct number. So we're going to say while true. This is the condition for the while loop. We could do a real condition. We could say something like while like input, and actually we'll say like user guess is not equal to random number. We could do something like that. That would work as well. But I want to show you using the break keyword. So instead we're going to do while true. All right, so what we're going to do is we're going to start by asking the user to guess what the number is, right? That's the very first thing we do every single time we ask them. We say, okay, make a guess. So I'm going to say user underscore guess is equal to, and then input. I'm going to say make a